Hello and welcome back. In this lesson, we're going to be looking at comparisons, conditionals, and loops. Now, if in the previous lessons you didn't understand something, hopefully by the time we're done with this chapter, it'll all become clear because this is going to be dealing with how 2b and 2equal and all these other things work under the hood. So the first thing you see is in the comparisons, I've thrown a debugger statement on there, and that's because when we go to chapter 3 in the spec runner, the comparisons are the first 11 tests that we run. So I'm going to click on those, and sure enough, you can see our debugger kick into action. The first grouping is right to left hand association, which means that it's going to evaluate something on the right hand of the evaluator, and then it's going to go to the left. So here it's going to first evaluate 90. We're going to see that right there. You notice that it picks this block of code first. So it evaluates C is equal to 90. Then it's going to set B equal to C, A equal to B, and so forth. This is what's known as the assignment operator when you have a single equal sign. So sure enough, whenever we ask the question, are these things equal to each other? So A is equal to B, B is equal to C, and C is equal to 90. Next, we have the unary negation operator, which is the bang or the exclamation point. And unary just means it works all by itself. It doesn't require anything else. So the first thing that's going to happen here is going to evaluate the truth or false statement of whatever the variable is or whatever the assignment is you're looking at. Then it's going to flip that. So first, bool is going to be equal to true, then it's going to flip that, and then it's going to be equal to false. Next, we have the bitwise negation. This one is a little bit tricky here. And the way this one works is it flips anything that is -1 into 0. And you don't see this very often, but one time you will see it is when you use index of, because remember, index of returns -1 if something can't be found. 0 is a valid placeholder. So by using the negation operator here, the bitwise negation operator, we can say create an array with 1 and 2, and then look for 3, which is going to be -1. Then if we get the bitwise operation of that, that's going to give 0 instead of -1. So without it, what we get here is -1. So 0 is equal to false, and if we perform the Boolean operation on that, we get false, false. So sure enough, that is true. It is true that it is false. That is what's confusing about speaking about comparison operators there. But we can see that there is no index of 3, and then we can make sure that it is false. -1 will pass on an truthy check. So if you do if -1 console.log yes, you can see that it printed it out. Anything that's not 0 or doesn't evaluate to 0 is going to be considered truthy according to JavaScript. Next, there is the unary plus operator, which isn't going to do much of anything except for if something is a number, it's going to make sure that it's a positive number, but here that doesn't do much of anything. Next, we're going to look at what's known as the prefix and the postfix increments. Now, I remember I don't like the plus plus and the minus minus operator. Here is one reason why, and that is because what they actually do can be confusing. So notice here I have two variables. One is I and it's equal to 0. The other one is j and it's equal to 0. If you put plus plus before the variable, that means to evaluate the plus plus variable first and then assign it. So in this case, whenever we perform this operation, it's going to be equal to 1 whenever you ask for what the value of it is. In the second instance with the post increment operator, first it's going to evaluate j. After it evaluates j, it's going to add 1 onto it. So whenever j is evaluated at runtime, it's going to be equal to 0. Afterwards, when you ask what the value is, it's going to be equal to 1. So let's run through it. Right there, whenever I was evaluated, even though I was evaluated, it made it equal to 1. Here though, whenever we evaluate j is equal to 0, but immediately after it runs, then it makes j equal to 1. So in order to avoid confusion, I like using the plus equal operator because I think that's just much easier to understand, and there are several languages that don't even include the increment and decrement operators like that. Just as we have the increment and the decrement operators, we have the prefix decrement and the postfix decrement operators, which is minus minus. It works just like the other one does. If you use the prefix, it's going to subtract 1 and then evaluate the statement. So I right now is equal to 1. When it runs to that line of code, I is going to be equal to 0. Then you have the post-decrement version, which is going to first check what the value of j is and then subtract 1 through it. So whenever you ask it at runtime what the value is, it's going to be equal to 1. But immediately thereafter, j gets converted into 0. Next on the list, you have your left to right expressions, and we're going to look at the logical OR values. So as we've seen before, using the double pipe symbol, that is the logical OR statement. And what it does there is it says, if something is falsy, then look at the statement on the right-hand side and then set name equal to that. So you can see here, name is equal to Bob because null evaluated as false. And then it jumped over to the right-hand side, evaluated that, and said set name equal to that. In the case of name 2, it's going to evaluate true on Tim, so it's going to completely skip John. And sure enough, we can see that name 2 is equal to Tim. This is what's known as shorthand evaluation or short circuit expression evaluation, which just means that as soon as a statement is guaranteed to either be true or false, JavaScript will stop evaluating. It will not continue along that path. Here in the long true, we can see it's going to be false, null, 0, empty string, and finally at the very end of all this, true is a true statement. So long true is going to be equal to true because it had to keep going along the path until it got to true. So we expect the name to be Bob, we expect that name 2 is going to be Tim, and we expect long true to be true. Next we have the logical AND operators. So whereas it's very common to see this short circuit evaluation used to set a default value or to make sure something isn't equal to null, it is very rare to see that inside of the AND statement to see it used like that, but it still works the same. Now when it comes to logical OR operator, if one statement is true, the entire statement is true. The only way something can be false is for every single thing to be false, and that is the only way you will get a false value. AND is the opposite. For AND to be true, every single statement must be true. If even one is false, the entire expression is false. So true and true, whenever we evaluate it, is equal to true. But whenever we test true and false, that is going to be equal to false. When we test everything like that again, it's going to be equal to 1. And remember there, it's because of that JavaScript does not evaluate logical expressions as Booleans. It evaluates them as the actual value inside of there. This makes JavaScript different than almost any other programming language, which would have just returned true. It's very rare to see anyone actually use this in this particular manner with an AND statement, but it does exist. The OR statement is far more common to say if something doesn't exist, then set it to a default value. And we can see here in the long false that even though everything up until the final statement was true, because the last statement was false, the entire expression evaluates to be false. And then when we run through it, is true 2 is equal to 1, but that evaluates as truthy, so that's still good enough. And then finally, is false, and is false 2 is falsy. Whenever you're looking at math expressions and comparisons, this will use PEMDAS. So 2 times 10 is evaluated first, then plus 1, and you get 21. If you want to change that, if you want to manipulate this, then you use what's known as the grouping operator or parentheses in your old PEMDAS equation. And then now 1 plus 2 will be evaluated first, and then it's going to be multiplied by 10, which is going to give you 30. So that shows how these different operators work and comparisons and the difference between left to right-hand evaluations versus right to left-hand evaluations. We've seen here in all these it evaluates this statement first, then the next one, whereas when we got up top, first it evaluated 90, and then it assigned it down the string. It didn't go the other way around. So that's been a brief look at the comparisons inside of JavaScript.